Hello everyone, this is part K of name reaction series, and in this video we are going to cover name reactions starting with alphabet K. In this video we are going to cover two name reactions, that is Kolbe'S Electrolytic Synthesis and Kolbe'S Schmitt reaction. Now covering our first name reaction, which is Kolbe'S Electrolytic Synthesis or Kolbe's Electrolytic Synthesis. This reaction involves the electrolysis of an aqueous solution of sodium or potassium salt of a carboxylic acid or a dicarboxylic acid, which result into the formation of hydrocarbon at the anode and liberation of hydrogen gas at the cathode. In this video, we will cover following name reactions. First, haloform reaction. Second, Hell-Volhard-Zelinsky reaction. Third, Hoffman-ammonolysis reaction. Fourth, Hoffman-bromamide reaction. Fifth, Hunsdiecker reaction. And sixth one, hydroboration reaction. Now covering Kolbe'S electrolytic synthesis for the preparation of alkane. For preparation of 1 mole of alkane, 2 moles of sodium or potassium salt of carboxylic acids are required. On passing electric current in aqueous solution of sodium ethanoate, we will obtain 2 moles of CH3COO- and 2 moles of Na positive ions. Now, first of all, covering reaction taking place at anode. Since anode is positive electrode, CH3COO- will migrate towards it. 2 moles of CH3COO- initially will lose 2 electrons, forming 2 moles of CH3COO free radical. Then the CH3CO free radical will lose carbon dioxide, that is why this is decarboxylation reaction, and we will obtain 2 moles of free radical of CH3. Then these two CH3 free radical will combine together forming CH3 single bond CH3, which is ethane. Now covering reaction at cathode, water will dissociate into H positive and OH minus. Since we are taking 2 moles of water, we will obtain 2 H positive and 2 OH minus. 2 H positive ion will gain 2 electrons and it will form H2, which will be liberated in the form of hydrogen gas. The side product will be 2 moles of OH minus. In case of electrolysis, whatever be the number of electron removed at anode is same to the number of electron gained at cathode. Now covering Kolbe'S electrolytic synthesis for the preparation of alkene. For the preparation of alkene, we are required with sodium or potassium salt of dicarboxylic acid. In this case, for the preparation of ethene, we are going to take potassium succinate. Upon electrolysis, potassium succinate will give CH2COO-, CH2COO- 1 mole and 2 moles of K positive ions. Then covering reaction at anode, this 1 mole of CH2COO- single bond CH2CO- will lose 2 electrons 2 moles of CO2, and ultimately CH2 will combine with double bond forming ethene. Then covering reaction at cathode, 2 moles of water will dissociate into 2H positive and 2H minus ions. 2H positive ions will gain 1 electron each, forming hydrogen gas. In this way, ethene, or which is commonly known as ethylene, is obtained at anode and hydrogen gas will be liberated at cathode. Now covering Kolbe's electrolytic synthesis for the preparation of alkyne. In this case, we are required with unsaturated dicarboxylic acid salt of sodium or potassium. For this example, we are going to take potassium maleate. Upon electrolysis, it will yield positive and negative ions. Negative ion will move at anode and there it will lose 2 electrons, 2 moles of CO2 producing ethine as the main product. And at cathode, 2 moles of H2O, upon electrolysis it will yield 2 moles of OH- and hydrogen gas. So hydrogen will be liberated at cathode. Now covering our second reaction, that is Kolbe's reaction or Kolbe's Schmitt reaction. In this reaction, sodium salt of phenol, that is sodium phenoxide, is heated with carbon dioxide at about 400 Kelvin temperature under a pressure of 6 to 7 atmospheres. Upon reaction, our carboxyl group is introduced mainly at ortho position and sodium salicylate is obtained. Sodium salicylate is the major product which upon acidification yields 2-hydroxybenzoic acid, which is commonly known as salicylic acid. In this reaction, a small amount of para-isomer is also formed. If the reaction is carried out at about 573 Kelvin, then para-isomer is obtained as the major product. Now covering example of Kolbe's Schmitt reaction, we are going to react sodium phenoxide with carbon dioxide at around 400 Kelvin temperature and 6 to 7 atmosphere pressure. Upon reaction, phenyl sodium carbonate is obtained, which undergoes rearrangement reaction basically at ortho position, forming sodium salicylate as the major product. Sodium salicylate upon hydrolysis in acidic medium forms salicylic acid. In this case, on increasing the temperature, we can also obtain para product as the main product. Sodium phenoxide used in this reaction can be obtained by neutralization reaction of phenol with sodium hydroxide. Thank you for watching this video. Please like the video, share it and subscribe to my channel. Thank you.